Okay, so we have 4 theorems today, and that's all we're going to focus on. And all it says is that if you have equal stuff, you have more equal stuff. That's literally what all of these say. So when you go through the examples in your homework, you just need to look at what you have and then refer back to these theorems. Okay? So like this one says if angle AOB, so this angle is congruent to angle COD, this angle, then our arc AB is congruent to our arc CD. So I kind of like think of it as like if your angles are equal, you like pull them out, make them a little bit bigger, and your arcs are equal. Does that kind of make sense? It's also vice versa. If your arcs are equal, you can bring them in and those angles are equal. Okay. This guy over here says if your angles are equal, and then you have these little chords, these lines that are inside your circle, those lines are equal. Okay, so a little bit different than this. It's a line, not just an arc. But also, this arc would be equal because it's kind of that same thing over here. And then just vice versa. If these lines are equal, then these angles are equal. Okay? So a lot of equal stuff. This one I think is one of the easier ones. Maybe that's a little bigger, I don't know. If your lines are equal, your arcs are equal. So if these lines are equal, these arcs are equal. Okay, so you notice on each of these, like, the angles make up the arc. Here, these lines make up your arc. Like, kind of like an enclosed little part of a circle. Okay? Do you have questions so far? Seems pretty basic. This is probably the only confusing one, I would say. If you have, I don't know what to call it, little half lines that are equal, but you also have to have a right angle. Okay, so that's the only one that has like a double thing. So if these little lines, so it goes from your center to be perpendicular to a chord, if those are equal, then these lines are equal, and vice versa. If these big lines are equal and you have right angles, then these little lines are equal. Okay? Like I said, just a bunch of equal stuff. Okay. So let's look at this one. Notice I have these little lines are equal and I have right angles. So that's kind of like this one, right? Little lines are equal and I have right angles. So what can I say that what else is equal? The chords. Oh, what a word. So these lines. GI is equal to, what do I call the other one? LGI. Okay. Well, since now these lines are equal, can I say anything about some arcs? Yeah. It's the exact same letters, but you gotta put arc sign on it. Have you ever done arc signs? Yeah. They're kind of fun. GI, arc, is congruent to LJ, arc. Does everybody see the difference between those two things? The blues are talking about the lines that go straight across. The greens are talking about the round arc parts. Okay? And that's all we can conclude there. Okay? Questions on that one? Okay, how about this one? It says I have 2 angles that are equal. So what else is equal? The lines. Yeah. These lines, WX, is equal to my other line, ZY. Anything else? The arcs. Yep. Same letters. Wx plus the arc is equal to zy with arc.
Do we have to do the congruent sign or can we do just the equal sign?
Yeah, I'm not too picky. Okay. Questions there. Okay. Here I got these little lines are equal and right angles. This little line is equal and a right angle. And that tells me. I'm worried about you. You got allergies? I'm sorry. It tells me this is 3.5 and it's got two little marks. So if this has two little marks, how long is this? 3.5. So what is my whole entire line? 7. So how much is this x entire line? 7. So x. That's just 7. Because we got this equal stuff here and our right angles, we can do that. Okay. Questions on that one?
Where's the x?
Right here.
Oh, okay.
Yeah? Yeah. Okay, this next one is a little bit different than the last one. I have little marks that are equal, and then it tells me this entire side is 10. But what's missing? The right angles. So since there's no right angles on either one, we can't say anything. What should we call it? No conclusion? Or none? Let's just go none. So when you have these little short guys, you have to have right angles or you can't do anything. That's like the only double whammy one. Okay. It doesn't necessarily work in reverse though. Here, this tells me that this entire side is 8 and it's equal to that side. Okay. We could break this down into triangles if we wanted to. Right, so you're telling me you don't want to, that's okay. So this little guy, what would I call this line that I just drew?
The radius.
A radius and a hypotenuse, yeah. Well, isn't this a radius, a hypotenuse? And all radiuses are the same, right? Okay, so we have this line that's the same, that has to be the same. And then this line is marked the same as this line. So that has, what's that? Yeah, so it has to be the same here. So x has to be 3.2.
I literally put the same thing, but I didn't do any of that.
You literally just like, it has to be it?
Yeah.
Oh, okay. Let's just stop asking that like yesterday. Okay. Oh, I was totally kidding. I know you. Okay, how are you feeling so far? Feel like we're a little concerned like this is too easy to be true. Yeah?
I'm waiting for you to add numbers in it.
Oh, numbers. I love them. Go back.
I don't want to.
It's just more little things. Okay, so again, these are just little theorems that it just tells you if you have something, you have something else. Okay? So like for this one, it says if you have a diameter, we all know what a diameter is, right? And you have a right angle. Okay? With me so far? Then you can say that this line is equal to this line. And this arc is equal to this arc. So I kind of think of it as like if you have a diameter and a right angle, then you're split in half. And those two halves have to be equal. Yeah. Was that sarcastic now?
Yes.
So does it make any sense? don't like my hats? Like, cause the diameter comes through half your circle, right? So then this half stuff has to equal that half stuff. Is your sarcastic? I don't know.
No, I get it.
Okay, more diameter stuff.
Oh.
If the diameter, so we got our same little diameter, and you know that your lines are equal, so this time we don't have a right angle, we have those lines are equal, then you know you have a right angle. So you're just given different things. So that first one, you were given a diameter and a right angle. This one, you're given a diameter and these lines are equal, and then you have a right angle. That's just like a bunch of like playing with different things. Basically what it means is that a bunch of stuff's equal. When in doubt, like 98% of the time, just like equal.
A question?
Yeah.
Are we gonna have to memorize this all?
No.
Jesus.
I think it'll kind of come through in practice. Okay.
You okay?
We're cute. Alright, last one. It says if AB is a perpendicular bisector of a chord. Okay, that's a lot of words. What does perpendicular mean? Makes a T. What kind of angle at a T?
90.
A right angle. So if I have a right angle, what's it mean to bisect? Go through it. Cut it in half.
Oh.
So if I have a right angle and then that line is equal to that line, so kind of like what we had up there.
We have a right angle on the other side.
What do you do? But this
No.
one's just
I thought
silly.
it was really honest.
Then this has to be a diameter.
Oh.
What?
Yeah.
Alright, that's so stupid. Obviously,
Obviously it's cut in the middle.
How was that?
I'm just gonna.
You weren't impressed?
No.
Oh, that was angry. Okay, let's get some numbers.
I think mine was better, but
Numbers make this more fun.
No.
Hmm.
Numbers make it worse.
Okay. I have a right angle.
Yep.
What would you guess that is?
10.
Wowzers, you guys are so smart.
I know.
How can I find X? Pythagorean theorem, what's my A and B?
We don't have an A.
X and 10. So X squared plus 10 squared equals 14 squared. Plug it in, find X.
196.
And then when you square them, all that stuff, what do you get? Give me one decimal spot. 9.8 sounds wonderful.
Oh, was that the answer?
96.
9.8, yep.
How did
Wow,
I get
that
that?
was easy.
Did you get it right? You're surprised?
Yes, I did. I'm literally dumb.
Yeah, well.
You just subtract
So whatever 14 squared is minus 100 and 1 square root of.
Correct.
I don't even know.
Yay, correct.
This one looks just like a headache.
Okay, ready? Let's think about this. If this whole thing is 6, what do we think that is?
3.
3. Anybody remember anything about a 3, 4, 5?
5.
This is a radius, so what's that?
8.
It's also 5.
Wait,
it's also
what?
radius. They're both radiuses. They both come from the center to the side. So what's X?
5.
Isn't that the funnest?
No.
That was actually
I'm not
pretty
even
easy.
great. I'm hating on the math.
Is it getting harder? Is it gonna get harder?
Not really. I mean, I guess I don't
I feel like that's a yes.
Okay. Alright. What would I call X here? A radius. So let's think about this. You see how I got like this right angle here? And I like right angles.
Well,
What is this line called?
and the radius.
A hypotenuse and a radius. So how long is this using? It is X long. Everybody with me there?
Pythagorean theorem.
You don't have a number.
It's 4.5, isn't it?
What is 4.5?
The bottom.
The bottom is 4.5.
Half line.
Oh
my God. I didn't know what that was called.
So how can I find X?
1.9 squared plus 4.5 squared.
1.9 squared plus 4.5 squared equals X squared. What's X? idea what that was?
Yes, it is.
This is just too much. What the heck?
How do you
4.8,
guys
4.9?
type that fast?
4.9.
X equals 4.9.
So anytime you have a right angle, I would automatically try to make a right triangle. And a lot of times you're gonna have, I mean like always, by a lot, always, you're gonna have a radius as your hypotenuse.
Okay.
You're not convinced?
No. It's math.
Okay. Alright, here. What do we call 12? A radius. This is 9, so I need to find that guy. But what is x talking about?
The whole line.
The whole thing. So we'll just have to do one at the end.
Multiplied by 2.
Multiply by 2. Yeah, okay. So x is the whole thing. We're only gonna find, we'll call him y. Does that make sense? Okay, so set up my Pythagorean theorem.
Sorry.
I'm gonna set up my Pythagorean theorem. Nobody?
We always type much faster
This is
than I
probably
can
dumb
write.
question.
Mine's online.
Because x is the whole thing.
7.9.
Well, I said set up my Pythagorean theorem,
Oh, sorry.
not x.
9
Mhm.
squared
X
plus b
by
squared equals 12 squared.
9 squared plus b squared equals 12 squared. And what'd you get for by?
7.9.
Okay. So then
Times it by 2.
times it by 2 to get the entire x.
15.9.
15.8.
Yep.
Questions there? You don't go into the 690 here.
Even in the
I have the
Okay, good.
Okay. My next one. What do we call this line that's 24?
The
A diameter. So my friends are radiuses. How big would my radius be?
12.
12. Everybody good there?
Yeah.
You notice I have a right angle. And I can make a triangle. That's a radius, right? So how long is that line?
12.
How long is this guy? 5. So what's my Pythagorean theorem look like?
5 squared plus b squared equals 12 squared.
5 squared plus x squared equals 12 squared. So what's x? There we go. 10.9. Okay, questions there? Last one. What do we call x? A radius. On your paper, draw a right triangle somewhere. No, like on the circle, sweetheart.
You said on your paper.
I know, I'm sorry.
My lord.
Okay, do you guys draw this guy?
Yes.
Okay.
You didn't
That
do that problem.
red line I just drew, how long is it? It's a radius, so it's x long. Okay? Everybody good there?
Yeah.
Oh, I did not. 4 squared
This guy is
10.
10. So set of my Pythagorean theorem.
4 squared plus 10 squared equals
How do we feel?
pretty easy.
If you don't know Pythagorean theorem, woof the boy.